All right, let's do something fun. We're going to jump in a time machine, and we're heading way back to the very dawn of home computing. We're going to take a look at how a whole generation of us first got our hands dirty and learned to talk to a computer using one of the most beloved machines ever made.
So you flip the switch on your brand new Commodore 64, and this is what you see. No desktop, no icons, no mouse, just that iconic blue screen and a little flashing cursor. And that wasn't just some welcome message, it was an invitation. That single word, ready, was the computer looking right at you and saying, okay, I'm listening. What do you want me to do?
Now you see that 64K RAM system part? That means the computer had about 64,000 bytes of memory. But here's the catch, and it was a big one. You couldn't actually use all of it. A huge chunk of that memory was already being used by the system itself, by the very tools you needed to program it. So what you were left with was this number, 38,911 bytes. That was your entire sandbox. Every command, every word, every single character of your program had to squeeze into that little space.
So, with that tiny amount of memory to play with, how did you actually make the machine do anything? How did you turn that blinking cursor into a program? It all started with one simple, absolutely fundamental rule.
This was it. This was the first unbreakable law of Commodore BASIC. Every single instruction had to start with a number. And it wasn't just for keeping things tidy. It was literally the only way the computer knew what order to do things in. It would just start at the lowest number and work its way up.
So, let's see how this actually works. You'd type your first command, maybe 10 print hello, and then you hit the return key. And nothing happens, which is weird at first, right? But that's because the line number tells the computer, hey, don't do this yet, just store it for later. So you add your next line, 20, print John. Now, to see the program you've built, you just type list, and then for the magic moment, you type run. And boom, the computer executes your commands in order, printing hello and then John right on the screen. It's so direct, so simple, and honestly, so cool.
Okay, so printing a message is a great start, but a program that just talks at you is one thing. The real fun began when you could make your programs interactive, when they could actually have a conversation with the user.
And to have that conversation, your program needs a place to remember the answers you give it. And that's exactly what variables are for. Just think of a variable as a little labeled box in the computer's memory. You give the box a name, like say AA for apples, and then whatever the user types in gets tucked away in that box so you can use it later.
Check out how this works in a real program. Line 10 uses the input command to ask a question, then it stores your answer in that variable we called OO. Line 20 does the same thing for apples, storing it in AA. Then, line 30 does a little math. That asterisk just means multiply, and it puts the grand total into a brand new variable, CC. And finally, line 40 prints out the text total cost, along with whatever number is inside that CC box. It's a full-on interactive calculator, all in just 4 lines of code.
Of course, let's be real. Nobody writes perfect code on the first try. You're going to make typos, you're going to mess things up. But think about it. With no mouse and no fancy software, how in the world did you fix your mistakes? The answer was actually really clever and very hands-on.
And this is what was so brilliant about it. Your code wasn't hidden away in some separate file or window. After you typed list, your entire program was just there. It was live text on the screen, and you could move your cursor anywhere you wanted, up, down, right into the middle of a line. The screen was your editor.
So you basically had 2 ways to fix stuff. If you saw a typo right after you made it, easy peasy. You just hit the delete key, which is basically the backspace key, and erased it. But the real game changer was the cursor keys. You could literally drive that flashing cursor all over the screen. You could go up 5 lines, move to the middle of the word, type right over your mistake, hit return, and the computer would instantly update that line in its memory. It was amazing.
So this was pretty much your whole editing suite. You could zip around with the cursor keys, erase with del, or hit the inst key to make some space to add new letters. Oh, and getting rid of a whole line? It was brilliantly simple. You just typed the line number by itself, hit return, and poof, it was gone. Just vanished from the program.
So once you got comfortable with writing and fixing code, you could start giving your programs some real personality. And more importantly, you could start making them smart. It was time for a little bit of color, some style, and a healthy dose of logic.
Adding color was just wonderfully weird. You didn't type a word, like red or blue.
Instead, you'd hold down a special key, like the control key, and press a number. And on the screen, you wouldn't see a color. You'd see this bizarre reversed symbol show up right in your text. It looked like garbage. But when the program ran, the computer would see that weird symbol and know, okay, from now on, make all the text red.
And you had a whole bag of tricks like this. You could turn on reverse video to get that classic white text on a blue background look. You could even embed secret codes that would clear the whole screen or jump the cursor to a specific spot. You could orchestrate the entire layout of the screen, all from inside a single print command.
But to make programs truly powerful, you had to teach them how to repeat themselves. And that's where loops came in. Say you wanted to ask for the price of 10 different things. Instead of writing the same code 10 times, you just wrap it in what's called a for and next loop. You'd say something like, "Okay, computer, for 10 times do this little block of code and then go to the next one." It was an incredible time saver.
The other ingredient for making programs feel smart was teaching them how to make decisions. And for that, you had the if-then statement. It's exactly what it sounds like. You could ask the user, "Do you want to run this again? Y/N." And then your code could check their answer. If their answer is Y, then go back to the beginning. That simple logic is the absolute foundation of all interactivity.
And really, that was the whole secret. Repetition with for next loops and decision-making with if-then statements. Those two simple ideas were the fundamental building blocks. And with them, you could build literally anything, from a boring business spreadsheet all the way to a massive, sprawling adventure game.
Think about it. Starting with nothing but a blinking cursor and just 38,000 bytes of free space, a whole generation learned how to build entire worlds. These simple tools didn't just teach us how to code, they taught logic, they taught creativity, and they taught us the incredible power of bringing an idea to life, one line number at a time. The only limit, truly, was your own imagination.